Okay. Assalamualaikum, and a very good morning to everyone who's with us in the Faculty of Engineering FB Live. I'm Sharin from the Faculty of Computing, your moderator for today. First, I would like to welcome all our viewers to the Faculty of Engineering UTM Distinguished Lecture Series. And we are very fortunate today to have Professor Mark Sanderson from RMIT University, Australia. And he's going to talk on creating conversational search system. And to start our series today, I would like to invite the Dean of Faculty of Engineering, Professor Dato Insinyur Dr. Muhammad Rafiq, to introduce our speaker. So, hand to you, Dato.
Thank you, Sharin. Assalamualaikum warahmatullahi wabarakatuh. Hello, welcome everyone. Welcome to our 65th UTM Engineering Distinguished Lecture Series. My name is Muhammad Rafiq and I am the Dean of Engineering, University Technology, Malaysia. Today, it is my utmost pleasure to welcome our distinguished speaker, Professor Mark Sanderson from RMIT University, Australia. Now, before I mention a bit about our distinguished speaker today, just want to say sorry to Mark because there was a bit there was a 2 hours difference between Malaysia and Melbourne. So it is planned. The plan should be 9 a.m. Malaysia and 11 a.m. Melbourne, but I mistakenly put 11 a.m. Malaysia. Yeah, so that's why we are a bit late today. So sorry on my behalf for the confusion. Anyway, a bit about our distinguished speaker today. Mark Sanderson is Professor of Information Retrieval at RMIT University, where he is head of the RMIT Information Retrieval Group. Mark received his Ph.D. in Computer Science from the University of Glasgow, United Kingdom in 1997. He has raised over $10 million in grant income, published hundreds of papers, and has over 9,000 citations to his work. He has 25 current and or past PhD students. In collaboration with one of his students, Mark was the first to show the value of snippets, a component of search interfaces which are now a standard feature of all search engines. One of Mark's papers was given an honourable mention at SIGIR's, the Special Interest Group on Information Retrieval, in the year 2007 Test of Time Awards. Mark has been co-editor of Foundations and Trends in Information Retrieval, Associate Editor of IEEE Transactions on Knowledge and Data Engineering, ACM Transactions on Information Systems, ACM Transactions on the Web, and Elsevier's Information Processing and Management, and also served on the editorial boards of IRJ and JASIST, that is Journal of the Association for Information Science and Technology. Mark was the General Chair of the Association of Computing Machinery SIGIR in 2004. He was also a PC Chair of ACM SIGIR 2009 and 2012. Prof Sanderson is also a visiting professor at the National Institute of Informatics in Tokyo. So that is a brief biography of our distinguished speaker today. Here now is Professor Mark Sanderson from RMIT University, Australia, with his talk entitled Creating a Conversational Search System. Professor Mark Sanderson, over to you.
Okay, thank you very much. And apologies again for the confusion about me starting this talk late. So let's see if I can get this system working. So I'm just going to, there's going to be a sort of a strange echo effect for a start. If I share that screen, do that, and then, so let me just tell you, so I'm broadcasting to you from my house, and as you may or may not know from the news, the city of Melbourne has been in quite a lockdown for a while, so there are no hairdressers open, and so I've been kind of enjoying looking like a student again. letting my hair grow long. My wife is very angry and threatens to cut it in the middle of the night, but for the time being, it's still there. And hopefully hairdressers will be opening in the next week or two. This is a picture of the city of Melbourne. This is about as close as I got to the city centre in the last 6 months. We've been in various stages of lockdown here. I live just further down the coast, but I thought I would show you a photograph I took of the city. And Sharin, who I was very fortunate to have as a PhD student, worked at RMIT, which is in the center of the city that you see there. So let me start with my talk. And hopefully you can see, I'm just going to mess around with...
Yes, Prof, we can see. Thank you. Yep, it's good.
Okay, great. So let me start with my talk. So the talk I'm going to talk today is called Creating Conversational Search. This is who I am. I presume you can also see me moving my pointer. Is that also correct?
Yep, we can see the pointers as well.
You can see the pointer?
Yep, we can. Yes.
Thank you for confirming that. So yeah, so this is my website. This is my Twitter account. So I just want to sort of talk a little bit about history, how far we've come. We have, as was very kindly said in the introduction, I'm a professor of information retrieval. And when you think about information retrieval, you think about traditionally libraries. And probably when we think about libraries, we think about them providing one particular kind of service, which is getting access to books. So these ladies and this gentleman here are organizing the index that enables people to find books, enables them to find objects. And so, you know, we have an equivalent of that today, which is we have search engines which don't necessarily find us books, but they find us web pages. So you type in a query. For example, this is a query about a conference that's happening in Vietnam right now. You type in that query and you get back web pages that are about that particular query. But actually, libraries used to do more than this. They used to help people not only find books, they used to help them find answers to questions. For example, here in this film, this very old film from the 1950s, people would write to the head of the library and ask them to answer particular questions. Let me just jump forward in the video. So this is the head of a library, a librarian in Sheffield, would actually get letters, not just from the public, but from companies asking him if he could help them with questions. What's the address of this particular organization? What's the standard that's used in a particular industrial process? And people at the library would go and find answers to those questions. Well, of course, we see that as well today. We see our search engines are able to answer very simple questions. You know, what is the capital of Australia? A search engine that we use like Google will give you that answer. But the kinds of questions that these systems are answering are rather straightforward, rather simplistic. And actually what we want is we want systems that are more sophisticated than that. I realize I've started a little bit late, so I might just rush through this part. There's a video, just to show you one last video, there's a really interesting, if you want to sort of a vision about what we should be actually aiming for, you might want to go and take a look at this video that was made by Apple back in 1987. So where are we? 33 years ago. And it was about a vision about a computer system that would be made in the future. So there's a few things they didn't get right. This is a university academic coming to his office. And I don't know about you, Sharin, but my office doesn't look like this. But his computer doesn't look too different from some of the things that we have today. So that was a folding computer. It looks a little bit like an iPad. And the device is talking to him. It's giving him updates on what he needs to do. In fact, what it's doing is it's reminding him that he needs to do a lecture this afternoon, and that the lecture and he hasn't prepared any notes for it. And so the whole little piece of this video is about the way that he uses the device to connect him to other individuals and to also enable him to get his lecture notes ready for the class that he'd forgotten about. And one of the key things that you get with this system from this video, and I realize this is a terrible quality video, we're looking at a digitization of an old VHS tape, but this is the best quality that I could find on YouTube. But what he does is he actually has a conversation with the computer. And the reason he has a conversation is because his questions are more complex than what's the capital of Australia. He needs to know, he needs more complex answers. And in order for those answers to be found, the machine needs to interact with him. And he needs to provide additional information in order to achieve the goal of finding this this complex answer to his complex question. If you ever have time, I urge you to go and watch this little video. It's really quite an interesting pointer as to the kinds of systems that we want to be building in the future. A system that you know, interrogates a range of different data sources, links you up with colleagues and friends. There's a whole bunch of really quite fascinating things, and this is a really interesting video if you're looking for a vision of the future. It's also quite rare in the sense that often these visions of the future just don't get things right, but it's really quite striking how forward-thinking this particular video is. Something that you talk to, screens that you touch, no keyboard, video conferencing, speech recognition, text-to-speech generation. It's a really cool video, and definitely one of those old ones that's worth a look. I mean, the camera is looking a bit big, and I'm not sure I like the design. It's a little too much on the bezeled edges, but still a nice video. Okay. And, you know, obviously we have equivalents today, things like, you know, Google Home, Amazon Alexa, Microsoft's Cortana, Apple's Siri. And we're starting to get to things that are perhaps a little bit like that knowledge navigator, except that really what they're mostly good for is for turning on lights or setting a timer or telling you, you know, who were the members of Fleetwood Mac, or, you know, very simple sort of factoid type questions. So what we want is we want to get to something that is much more complex than that. We want to get to something that can answer complex questions. And what I'm going to do today is I'm going to talk a tiny bit about sort of where we think how we think we can actually achieve that future of conversational searching systems. And then I'm going to tell you about some of the research that I and my PhD students at RMIT have been doing to try to better understand how to generate a conversational search system. This is not something that will be solved in a couple of years. This is a topic that we will be working on, I suspect, for at least a decade. I think a conversational search system is actually a combination of three things. And we've got some existing technologies right now. We've got information retrieval systems, we've got chatbots, and we've got dialogue systems. By dialogue systems, what I mean here is systems like maybe you phone up your cinema and ask to book some tickets on your to go see a movie. And the system enables you to talk to it, and it uses speech recognition, but it follows a very rigid dialogue. But those dialogue systems are starting to build data retrieval and information retrieval capabilities, and they're starting to head towards conversational search. We also have chatbots. Probably the most famous is the JASIST chatbot that Microsoft has created in China, which is using IR capabilities to just try and find sentences that it can give back to you based on what you say to it. And the system's goal is just to keep you engaged, just to keep you entertained. It's not really trying to answer any sort of complex questions. Search engines, on the other hand, have always tried to answer queries, and they've traditionally done that by retrieving documents. And they've traditionally not had much of a notion of state. They haven't sort of paid much attention to what you asked before. But increasingly, state is becoming a part of those systems. They're starting to understand that they're having a session with you. They're engaging with you at some level. Separate to that, we have these kind of interactive IR systems, which are now building speech and language capabilities, which enable them to become these conversational search systems. So it's going to be a coming together of these different approaches that will get us to a conversational search system. Now, one of the key aspects of all of this is using natural language processing technologies, which enable you to take a complex question and match sections of documents that will retrieve passages that will fit what you're searching for. And I'm not going to talk very much about those technologies today. The main thing to talk about, the main place where you could go find out about that would be at something like ACL, the Association of Computational Linguistics. There's going to be a conference in Thailand next year. And ACL is a place where you can go find out about a lot of those kinds of technologies. What I'm going to talk about today actually is more in this little area here about user task modeling. One of the things that you don't see very often at conferences like ACL is research that spends a lot of time trying to understand users. And this has been something that's always been of interest to me and to the research group at RMIT. So I want to talk a little bit about some of the user research that we've been doing at RMIT in order to understand how we might build conversational search systems of the future. I'm going to talk about 5 pieces of work that have been done by 4 of my students. So one of them's done a couple of pieces. So an old student of mine, Johanna Trippas, who now is a research fellow at the University of Melbourne, has published a couple of papers. In fact, she's published many papers, but I just wanted to highlight a couple. I'm currently working with Leila Tavakoli and Valeria Bolotova, who are both current PhD students, and they've done some very nice research in their own respective areas. We also collaborated with a researcher from Tsinghua University, Jing Wu, and she has just got a paper published at CIKM based on the work that we're doing. Valeria's work has also been published at CIKM. Leila's presenting at the Doctoral Consortium. Johanna's published in the past at CHEER and at the Clay Conference. So let me tell you a little bit about that work. And what I'll do is, can I just check, by the way, you'd like me to finish in about 35 minutes, is that correct?
Yeah, 35 to 40 minutes, Mark, yeah.
Perfect. And you'd like me to leave some time for questions as well, I guess?
That's right, yeah.
Great, okay. So what I might do, we did start a little bit late, so what I'll probably do is I might go through this work at a certain pace, because I'd like to leave lots of time for questions so that, we can have a conversation, because I think that's usually the better way to make these things work. So what are the, let me tell you about the first couple of pieces of work, because the first couple of pieces of work really go back to the start of conversations. Johanna decided that in order to understand about conversations, we actually need to study them. And so she set up a very interesting experimental methodology. She recruited sets of people and put them into pairs. She had one person who was a seeker, who was given an information need, and one person who was an intermediary. And the intermediary had a computer. He had a keyboard, he had a mouse, and he could work with that particular device. And what this little monkey is doing here, the seeker and the intermediary couldn't see each other. They could only hear each other. And so Johanna was very interested in understanding spoken conversation and what spoken conversation looks like when you're trying to find an information need. So she published this work at CHEER, and I'm just going to give you some sort of highlights of some of the things that she observed. So one of the things that she found was that when you have conversations, whereas more typically when you're using a search engine, a query asks for a simple atomic thing. and the search engine returns that. Often with conversations, we ask for more than one thing. She often saw the seekers would actually ask for multiple actions in one particular utterance. She also noticed that the seekers would actually expect the intermediary to actually do some of the decision making for them. So because the conversational channel, because this channel of just speaking is a rather low, doesn't carry a lot of information in it, low bandwidth, I suppose. One of the things that she saw happening was the seekers would actually expect the intermediaries to actually make some decisions themselves. So maybe expect people to rewrite queries, expect the intermediary to just sort of automatically start presenting the results without the seeker asking for it. They also noticed that voiced queries tended to be longer than the typed equivalent, perhaps not too surprising that. She also saw really quite sort of unusual interactions. So for example, a seeker giving the intermediary a search task that almost was like an algorithm. You know, try and find rivers in Turkey and Iraq that have dams, and essentially asking the intermediary to run a repetitive search. So there was kind of quite a lot of offloading of cognitive effort from the seeker to the intermediary when you were interacting in this particular mode. There was also an expectation that the intermediary, a bit like that Knowledge Navigator video, would be able to interpret graphics. So to be able to actually say, I'm seeing a graph right now that's looking at population growth for the first 10 years of the 21st century, and also actually explain that you can see data for Sydney and Melbourne and Brisbane and things like that. So she saw quite a lot of expectation by the seeker of the intermediary. Outputs from her research are many and varied, but one of the really interesting outputs from her work is a data set that she's made available of all of these spoken conversations. The work she did was of such interest that people at Microsoft invited her to come and work with them. They also had created a data set of conversations, and she was involved in helping that Microsoft data set get marked up with metadata to enable the conversations to be better understood. Now, that's not the only place where you can go look for conversations. There's actually huge numbers of conversations on the internet, and actually huge numbers of conversations related to information seeking. One example of that is the Stack Exchange website. So Stack Exchange has huge numbers of people coming to it, asking questions, and often these are questions that they can't get answered on Google. And there's a community of people on Stack Exchange who are keen to help those people who are asking the questions. And the site is this kind of great coming together of askers and responders, people who want answers to questions, people who can provide answers to questions. So Layla's been looking at this data because there's a structure to it, and you can identify different elements of that structure. It's very easy to identify the original question that's asked by the asker. It's very easy to identify the accepted answer, the final eventual answer that the asker said was a good answer. And they actually click a button that says accept answer, and that kind of closes off the conversation. But between asking that initial question and providing that accepted answer, you see clarifying questions, and you also often see answers to clarifying questions. And it turns out it's easy to identify and to spot these different elements of the conversation. And then that gives you an opportunity to analyze that, to better understand the way that conversational search systems might get built. So just to sort of give you a little bit of highlight for what Layla's been doing. So she's been looking at the volume of clarifying questions, and she's been studying changes in different areas. So there's a section of Stack Exchange on quantitative finance. There's a section on English language. There's a section on science fiction. There's obviously a huge section on computer science, that's Stack Overflow. And she was looking at, for example, the number of times that clarifying questions are actually answered. It turns out it's actually not that often. Often people ask clarifying questions, and somewhere in the range of 85 to 90% of clarifying questions are never answered by anyone. But generally, the next most likely outcome is that it is the person who asked the original question will actually answer that, that particular type of clarifying question. There's perhaps some patterns in here that, you know, sometimes people who answer the clarifying questions are actually different individuals. And perhaps in the case of quantitative finance, if I have a finance question, it's probably a very personal question. So it's very unlikely that anybody else would know how to answer that clarifying question. But in more broad topic areas, such as English language and usage, there's actually a chance that a wider set of people could answer that question. The other thing that Layla's currently doing is she's actually creating a typology of different kinds of clarifying questions. So there are very straightforward clarifying questions, sort of almost kind of sorting out ambiguity problems. You know, did you mean this or did you mean that? But there's a much wider range of clarifying questions. And in research that she's currently working on, she's trying to understand those different natures of clarification questions that might get asked when you're having a conversation to try and solve a complex information need. So those are areas of research which are very focused on text or words. So we've got a system, a research on systems that use the audio channel, systems that use just kind of textual interaction. And those two research pieces just look at the nature and the pieces of conversations. But it's possible, as we saw with that Knowledge Navigator video, that a system might be a combination of voice and graphics. And so it's always interesting to ask ourselves, how might people interact with systems that provide answers? There's a great deal of research on systems that, a great deal of research on how people interact with traditional search engines, for example. This is a classic image released, gosh, I don't know, 15 years ago of eye tracking data about how people look at an old Google search result. You can find this image by typing in Google golden triangle, because this looks like a triangle and it looks like it's the color of gold. And it's just an indication of where eyeballs go when they look at a Google search result. So this is the first result here. This is the second result. This is the third result, fourth result, and so on. These are some adverts in the old way that Google displayed sponsored links. And it was called the golden triangle because the idea was if you were doing search engine optimization, you wanted to be at the first, second, third, maybe fourth position, because that's where all the eyeballs went. Actually, that research, Naomi and maybe even Shirin, particularly Prof Naomi might remember this, because I've shown this slide many, many times. And I forgot to say that I had a very enjoyable time about 11 years ago visiting JB and giving some lectures. And I'm sure this graph, this image showed up in those lectures from 11 years ago. If I went back to JB to do some more lectures on search, I'd have to talk about probably this, which is that actually the way that we interact with searching systems has changed. And they think it's to do with the way that we use mobile phones. Our use of mobile phones has encouraged us to scroll down more and to look more vertically. So some recent research doing eye tracking studies as to and studying how people interact with Google have discovered less of a triangle and more of a sort of a vertical line of attention. However, for all of this research that's been done on interactions with search engines, it turns out there's actually been very little research on eye tracking for search engines that return answers. So this first example here is a traditional search output, just listing web pages that match a user's query. But these two on the middle and on the right indicate results where there's an answer being provided. In this case, this is a sort of a fairly standard answer to a question this is one that presents multiple answers to a question. And we were working with this student who was visiting us from Tsinghua University. And she was just at the end of last year, in the beginning of 2020, just before the whole COVID thing broke. She ran a series of experiments. She got about 30 users to come in from Melbourne and use our eye tracking system that we've got at the university and study how people interact with these different kinds of search systems. So a traditional system, S1, a system that has one answer, S1 and S3, and a system that has multiple answers that someone can navigate through, S4 and S5. The difference between the even and the odd numbers here is the odd numbers have answers that are bad, answers that don't really answer the question, and the even ones, S2 and S4, have answers that are actually useful to answer the user's question. So let me throw up some tables of numbers that this student generated. And some of these numbers might seem a bit obvious, but it was really quite amazing to us as we were researching the literature reviews in this area to discover that no one's actually done this, at least not in the academic field. So how long, so for example, how many results do people click on when you don't have an answer? Typically about 2.5. How many when you've got an answer? It goes down substantially. Very few results are clicked on when you've got an answer there. How many sessions have no clicks at all? Well, when you're showing a traditional search output, very, very few sessions have 0 clicks. When you're showing results with good quality answers, you have a huge number of interactions where there are no clicks at all, substantially higher than this number. How much dwell time is spent on the various pages? Well, if you show an answer, people spend less time on the answer page because they get the answer. And while these results might seem a little obvious, they've never been actually measured before. And what's always interesting about doing measurement of these things is it's good to know exactly how much things change. So while we would expect putting an answer in the results would reduce the dwell time, we can see by how much the dwell time is reduced. While we would expect showing an answer in the search results would increase the number of sessions with no clicks, I don't know whether we would have expected it to be, what is that? About 4 times higher, 4 or 5 times higher. Yeah. 9 times higher. What am I doing? Yes. Okay. Other results, I'll skip over that one actually. I don't think that one's as interesting. But another thing that she was looking at was where the eyeballs go when looking at the results. So this is a traditional search result page. So everybody focuses on result number 1, then a bit less on 2, a bit less on 3, a bit less on 4, a bit less on 5, and goes down. When you have a good quality answer, just so much of the fixations of the eyes goes on that answer and then very little attention on the later results. If the answer has mistakes in it, if it's not a good answer, then there's more attention on the first result, but it's still, the answer gathers an awful lot of attention. So it's very important to make sure that that answer is actually good quality. If you have a large number of answers, so this idea of folding multiple answers into one banner at the top of the page, then the rest of the search results are barely looked at all. So just a nice example of some straightforward research that gives you an idea about how people interact with answers when they're presented in a search engine result page. There's another aspect of research that we've been looking at as well, which is the question of emphasis. So if I go back to my search result that I showed you earlier of this conference in Vietnam, we have certain, when you type in a query into Google or any of the top search engines, if your query words appear in the snippets of the search result, they're emphasized in bold. And there's an interesting question. Okay, so bold's a great way of emphasizing a word in text. How do you do it if you're doing it in speech? So supposing you spoke to your system and you wanted an answer to a question. Supposing you wanted to emphasize a particular word somewhere in that answer, how would you do that in a spoken way? So a very cool thing happened to Johanna a couple of years ago. Some people at Google Zurich, part of the Google AI group, approached her and said, we'd like to work with you to try and answer this question. So Johanna's got a lot of experience in doing crowdsourcing experiments. And she created a crowdsourcing system which enabled people to listen to different styles of answers. So you might have a question like, which guitarist inspired Queen? And then the answer would be spoken back at you. So she had these embedded sounds in a crowdsourcing interface, and then worked with, and then recruited a large number of users to try out different systems. What you need is you need a search engine that will generate answers, and you need something that will do a text-to-speech conversion, because you need these spoken answers. They had two text-to-speech systems. They had one produced by IBM, and they had one produced by Google. The systems that they tried different forms of emphasis. So one form of emphasis was to try a pause. You wait for a second before you say the word that you want to emphasize. Another way of emphasizing is to slow the rate at which you say a word. You just take longer to say that word. You can also change the pitch of a word. You can sort of try to raise your pitch to try and emphasize it. But the other thing you can do, and the Google system was able to do this, is you change the emphasis. There's just something about the way you stress certain syllables in a word, and it just makes that word seem more important. So they asked the crowdsourced workers to understand, to give them feedback on the informativeness of the answer, on the correctness of the answer, and then some questions on the way that the answer was actually vocalized by the system. And the strong result was that the emphasis approach that Google had made a huge difference for users' perceptions of whether the answer was informative or not, and also made a big difference as to whether they felt the answer was correct or not. So a really nice little piece of research that just looks at ways of ensuring that a conversational system is able to know how to emphasize things for your user to see and to understand. The final piece of research I'll tell you about is some work that my student Valeria has been doing, looking again at the way that people interact with answers to questions. So if this is a question here, oh dear, there's a spelling mistake there, wrong two, never mind. And this is an answer that's presented on a screen. Valeria used an eye tracker to try to understand where somebody's attention might go to. And in her case, just building on the things that Johanna did, she was using bold, emphasizing certain words using bold and color changes to highlight particular words in the answer that was produced as a result of a complex question. And one of the questions she asked herself was, well, if you're going to generate, how do you generate those highlighted words? How do you decide which words to highlight? In the old days, if you're just taking the words of a user's query, well, you just highlight all the words from the query. But we know that questions are longer, and we know that questions have a whole mixture of words, some of words which are more important, some words which are less important. And there may actually be words you want to emphasize in the answer that don't appear in the question. So there's an interesting question about how you generate the right kinds of keywords to highlight. And there's also a question about whether the words that you highlight can be predicted accurately by a particular system. So Valeria posed this really interesting question, and you see it in the name of the paper. Do people and neural networks pay attention to the same words? So she took a state-of-the-art neural network system and got it to say which were the interesting words in an answer. And then she looked at where people's eyeballs land on different answers and tried to see if there was a correlation between those two things. She did a bunch of other research. So she also looked at things like how long people would view an answer. People would spend longer time looking at a correct answer than an incorrect answer. But the most interesting thing was that she found that, that a system based on the BERT language modeling system, and one that's actually fine-tuned, and then a revised version of the fine-tuned one that uses the best heads from that fine-tuned BERT model, produced a better prediction of which words a user would look at compared to a traditional TF-IDF kind of approach. So that was a really nice piece of research where she was able to see how you could use language modeling and the latest deep learning based language modeling approaches to understand how to emphasize words within the answer to a complex question. And these are the results of the work that she, of the conclusions of the work that she did. So I've shot through a little bit of this talk, and that's kind of where I wanted just to sort of finish off. So let me just kind of recall what I've been talking about. So I've described a little bit of history. If you've ever seen me give talks before, you know I love talking about history. And I've showed some old videos that I'm sure a few of you have seen once or twice, but they're lovely old videos of libraries. And they just remind us that libraries are an interesting mixture. Not only things where you went to get books, but they were also things where you went to get answers. And we can see that over, you know, the last 2 or 3 decades, search engines have evolved from getting you news articles or books to match your query, or web pages to match your query, to actually starting to get you answers. But the kinds of answers that search engines get you are rather simple. They're rather straightforward. And what was where we're going to head to next is where that Knowledge Navigator video was pointing us to, which is complex conversations where we interact with systems in order to answer more complex, try to answer more complex questions. And I then told you about some research that we've been doing at RMIT to just to start chipping away at this problem. And as I said at the start, this is not a problem that will be solved in an instant. This is actually quite a complex, detailed challenge for the information retrieval community, and one that it is enthusiastically attempting to solve. So I think I might finish there, or just stop, and I'd be very happy to take any questions that you might have.
Yeah, thank you so much, Mark, for, I think this is a very interesting topic since nowadays people are started to become very serious in looking for information. And I think one of the things is right now is how people to actually ask questions. You know, they wanted to ask in normal languages, you know, but then I know some of the people, they have trouble in knowing what are the exact keyword. Okay, so I get one question from the audience here. So it's from Yogan Jayakumar. Hi, Prof. Mark, interesting topic. I would like to ask if code switching text, combining 2 or more different languages in a question will generate relevant answers. Has this been investigated? Yeah, I think this is a very common question for people that have, you know, more than one language talking, like Malay. We usually ask questions in Malay and English in one sentences. So what do you think about this?
This is why no, I'm smiling because, you know, in my job as an academic, most of my colleagues, Sharin, Prof Naomi, I'm sure your dean, everybody I encounter can speak more than one language. And that's because they have to be able to converse in English, because that's become the language that everything is discussed in. And I can't speak another language. I failed my school when I was at high school. I got one of the lowest scores possible for a foreign language exam. So it would never have crossed my mind. What a fascinating question, and thank you for it. Look, I think that would be a genuinely interesting topic to go and research. I don't think it's something that the community is thinking about, to be quite honest with you. There is a definite bias in the research community towards English. I think that's changing. And I've noticed 1 or 2 prominent language processing researchers who are sort of saying we can't just emphasize English. Of course, Mandarin Chinese has got a lot of data sets available for it. One or two of the other big languages, maybe some Spanish data sets are available. But that sort of combination element is really interesting. It's not something that Johanna covered in her work, and that would be fascinating to go and study, actually. Would it make things, is it likely that you'll actually do better? I don't know the answer to that question, but it's certainly a style of question that I don't know that I've heard anybody talk about. And I guess it's something that would be more voiced than written. Would that be right, Shireen? Would you be
Yes,
more like...
well, not really. I think if you look into Facebook and some, especially, I mean, people write comment. I mean, for those who has, you know, multilingual, they might, you know, ask question using both languages. So I think not necessarily in spoken, but also now in written too. Yeah. But then looking about this, I'm just wondering, would crowdsourcing be a help on this? I mean, creating a data set with, you know, with different languages. Because last time when I was in RMIT and I was doing crowdsourcing, I know Amazon Mechanical Turk is one crowdsourcing place we can do, and also Crowdflower, the one that I used before. But I noticed that Crowdflower is not there anymore. I think they changed. I don't know what happened. So what are the sources of crowdsourcing place that we can actually, you know, get people to do this crowdsourcing work? I think Malaysian researchers in this area, we are not very familiar with this crowdsourcing data.
So we've stopped using Crowdflower. Crowdflower are no longer interested in working with academics. So they'll only, if you've got like hundreds of thousands of dollars, Crowdflower will happily set up a contract with you, but they don't want to work with small-time operators. So unfortunately, the account that you were using no longer exists. So we use Amazon Mechanical Turk. There's actually lots of crowdsourcing solutions out there. So we recently discovered you know, some of the, you know, people like SurveyMonkey or Qualtrics, some of the people who run these questionnaire systems, if you talk to their business managers, they can actually find you people all over the world to answer your questions. Now, they do charge you. It's not cheap, but it's not ridiculously expensive. So we've run a couple of large surveys. And you can, and actually when you pay a bit more, you know, Amazon's kind of cheap and cheerful. You know, if you know, you sort of, you pay your money and it's a bit of a wild market out there. With some of these people like SurveyMonkey or Qualtrics, you know, you actually get a manager who looks after your job for you. And so if some people don't give you very good answers, you can ask the manager to go and get new people, and you can target particular groups. So we ran a survey where we wanted to interact with English-speaking people in certain Western countries, and they were able to sort of get us exactly the demographics that we wanted. Oh, they also had to have particular kinds of jobs, and they were able to get us access to those communities. So there's actually a very large range of crowdsourcing places these days. It's much bigger than when you and I were working together.
Would you say that crowdsourcing would be one way to actually help the problem with multilingual search questions?
Yeah, I mean, it certainly gives you, crowdsourcing is very, excuse me, crowdsourcing is very interesting because it certainly gives you access to community groups that you don't normally get access to. You know, if you do a user study in Melbourne, Melbourne's a fairly multicultural city, but you get access to quite well-off people, right? And you tend to get access to students. And so students are a particular age, they have a certain amount of money, they have particular attitudes, societal views, and they won't be necessarily representative of the whole world. So Mechanical Turk probably gets you access to a wider range of people. Probably not everybody, but yeah, no, crowdsourcing is a useful tool.
Yeah, I think that would be interesting because I think for search, I mean, look into pattern of search questions. Even for, I think what the students have here, we kind of got problem with the data set itself because mostly everything is in English. So there are students who are looking into Malays, so looking into even having something ontology like WordNet is very difficult to have. I mean, when we talk about conversational search engine, we are looking for something that, you know, people understand how people ask questions. I mean, it might being affected by the culture. I mean, how you ask questions. I think that will be some things that maybe people in this area would look into. I mean, I don't know, but in Melbourne, I've seen that, you know, English, those people, they ask straight to the questions. But for us here in Malaysia, Malays, we usually, you know, we don't directly ask the question. You know, there's some words that we might use. So I think these are the things that might be interested in this area. So is there any last word?
Oh, just other than to say thank you so much. Well, any last words? I mean, you know, it's very unfortunate. I mean, I was actually talking. I had the very good fortune of giving a talk to some people in Vietnam a couple of weeks ago, and they were actually asking very similar questions in the sense that, you know, I don't know if you noticed, but I was dictating to my phone at the very beginning of this lecture, and you know, it recognized my speech perfectly. Everything I said, it just turned into text, and I sent off a couple of messages to some people. And the people in Vietnam I was talking to were saying, well, you know, Vietnamese speech to text just isn't as good. I don't know what Malay speech to text is like. You know, one of the things that might be interesting for your community is to look to actually build some of these language models, but for Malay. I mean, the BERT system, for example. Now you need access to huge amounts of compute, but I wonder whether companies like Google or Facebook might be interested in supporting the creation of some of those language models for a language like Malay. You know, it's a big country. You know, the language is spoken widely. It might be interesting to see whether you could get some of those things solved, and then it might become more possible to look at language at sort of, you know, more sophisticated solutions to question answering problems. But the person who asked the question, thank you so much. That's a really interesting question. I'm gonna have to think about that for the rest of today.
Yeah, I think so. So I think we're come to at the end of the question. Is there any more questions from the audience? Okay, so we take one more question. It's from Prof Naomi. So she is asking, apart from voice features such as pause, rate, pick, and emphasis, do you think we can make use of video stream to better understand users' information need from their facial expressions to query answers?
What do you think? Yeah, I think definitely. I've realized during lockdown how useful video conferencing is. I often see people's faces, and I can see behind what they're saying. You know, I can see whether someone's unhappy or happy or stressed or so. Yeah, Prof Naomi, always there with great ideas. Definitely. Yeah, I think that's a very good idea. It's not something we've looked at. It's not something that our guys do. But yes, absolutely. I think there's a bunch of those kinds of things, because I don't know what you're like, but I've got maybe you heard somebody preparing some lunch in the kitchen next door. It's quite a big room, so we have a Google Home there, and you know, it's got a microphone that can pick up sounds from anywhere in the room. If it had a camera and you could deal with privacy issues, it might be able to start to understand who's asking the question. Are they looking at it? Just there's a whole bunch of interaction opportunities there that these things like Google Home and Amazon Alexa aren't yet picking up on. So yeah, I think, as I said, you know, this whole focus of conversational search, you know, Prof Naomi, when you and I were in Sheffield, where are we, 10, 11, 12 years ago, you know, information retrieval was getting a little stayed. It was running out of steam a little bit, because it was just retrieving documents and not much else. And this whole area of answering complex questions as opposed to just finding documents has revitalized the field, and it's going to be a very rich area of research for many years to come.
Yeah, I think maybe your lab also can move forward with this. I mean, you guys have started with tracking. I remember when I was there, I think there's one student who's actually looking at that. I don't really remember her name right now, but I know it was the start of this eye tracking with search engine at that time. Okay, so I think that would be that will be the end for today's talk. Thanks, Mark. I mean, it was a privilege for me to be your PhD student last time in RMIT. Okay, so I think I'll pass over to Prof. Rafiq.
Thank you, Sharin, for chairing the session. And thank you to our distinguished speaker today, Professor Mark Sanderson, for accepting our invitation to speak at our distinguished lecture series. It is certainly interesting, especially the one that you showed, Apple 1987 Knowledge Navigator. So back then, I guess it was just a dream, science fiction, but now it becomes a reality. So thank you so much again, Mark, for sharing your thoughts on this. And to all of you watching this webinar online worldwide, thank you for watching. Do stay tuned because we have many more lectures for you. Until then, bye-bye for now. Bye-bye.
Okay. Thank you, everyone. Bye.